Welcome again to the official YouTube channel of the New Intelligent Design. You know what I'm doing right now? I'm throwing this ball to the air and this ball falls to the ground. So maybe you had a clue. Our topic for today is about gravity. But maybe you say, oh, I know that. But what you are going to hear today, we're going to learn today, is different from what you were taught in school in science classroom. Okay, so I discovered the topic of intelligence. And after that, I've written a book about physics of intelligent design. I'm showing you here in the screen. And on that book, I also discussed the topic of gravity. Okay, why? Because whenever I read about science books or science articles, science videos, science images, and science explanation about gravity, I am not convinced. And you know, this video that you'll be, will be you are watching right now, we are going to discuss about general relativity about for Einstein that was explained by Einstein, and relativity talks about gravity, mainly about gravity, time, space, and the whole reality. But this video, we are going to concentrate ourselves about gravity. Why it's very important to understand about this gravity. Once you understand this video about gravity, you will understand that you were taught incorrectly in science. And you will say, what we are doing in science, we are wrong. And you will know that you are wrong because you are going to see my explanation that are right. Once again, I'm going to throw this ball and this ball into the air. One, two. Okay. So what is gravity? First, we are going to ask Newton, Isaac Newton. According to Newton, when we throw this ball into the air and this ball falls to the ground, according to him, I'm standing on the earth, okay? Surface of the earth. According to Isaac Newton, that there is a gravitational force, or he called it gravitational pull of the earth, that this ball is being pulled, is being pulled, is being pulled. I repeat, this ball is being pulled by the gravitational force of the earth. Meaning the earth that I'm standing right now, according to Isaac Newton, that there is a force that pulling this ball and you and everything that inside here, inside the earth, there is a gravitational pull that pulling this ball and me and everything to the ground. This is the very first explanation about gravity, and we are studying that in physics, in high school, in university, and we were taught in school that this is the first explanation of gravity. And, Isaac Newton also discovered the formula of gravity between two objects, two massive objects, two mass in space. And we are using that when we launch space rocket, missiles, or whatever inside in the space. So this is the first explanation of gravity. But according to Newton, according to where you were taught, that gravity is just a pulling force. The first explanation, the first scenario, and the first possibility about gravity. Is that right? Is that correct? Well, maybe some of you said, well, Isaac Newton said it, therefore it is true. Okay, but here comes another possibility, another explanation, another scenario. Okay, again, I'm going to drop this ball to the ground. I'm going to drop this ball to the ground. I'm going to throw this ball to the air, and this ball falls to the ground. Well, the second scenario, the second possibility, the second explanation is that this ball is, there is no such thing as gravitational pull. Meaning that this earth that we are standing, that we are living, has no force to pull this ball to the ground. So why this ball moves to the ground? Why? Why? Okay, the second scenario and the second explanation is about Einstein. We are going to go now about Einstein. According to Einstein, the reason why this ball, when you throw this ball to the air and it falls to the ground, according to Einstein, this ball is being pushed by space to the ground. What do you mean by that? You know, we are living in a space, okay? This universe, this earth that we are living, is inside a space. According to Einstein, every massive of every object inside space, they create curvature of space. What does this mean? It means that if this ball is Earth, okay, if this ball is Earth, and this ball is inside space, around this Earth, the surface of the Earth, because the Earth consumes space, this surface, there's a pressurized space or a squeezed space. Some other calls them graviton, but I call it squeeze. Squeeze. There is a space that's being squeezed by object inside the space. For example, if this ball is the Earth, this Earth, around the surface of the Earth, there is a squeezed space, pressurized space, and this pressurized space is the cause of this ball falls to the ground. So in other words, the second scenario is that gravity is not a gravitational pull. There is no such thing as gravitational pull. Gravity is just simply space force this ball to the ground. It is the space that squeeze this ball to the ground due to the squeeze space caused by the earth. Is that correct? We are going to see if this which one is correct, which one is wrong. So I will repeat the first scenario, the first explanation. When you drop this ball to the ground, according to Newton, this ball falls to the ground because there is a gravitational pull of the earth. Okay? And according to Einstein, the reason why this ball falls to the ground because this ball is being pushed by space to the ground. Second scenario. The third scenario. I didn't know it is possible about the third scenario, but probably true. But let us see which one is correct. So I'm standing here on the earth. Okay? The earth is one object. And I have the ball in the other object. When I drop this ball, when I throw this ball to the ground, and this ball falls to the ground, the possibility that the ball stays on the air and the earth goes to the ball. Assuming that there is the earth, it is the ball, okay? This is the earth, this is the ball. So when you pull this, supposed to be this ball will stay on the space and the earth goes to the ball. The third scenario, the third possibility. We don't know if it's wrong or right, but there probably possibility. So the first scenario, the first explanation, the first possibility is that when you drop this ball to the ground, the earth pull this to the ground. The second scenario, the second possibility, the second explanation is that when you drop this ball to the ground, the space pulls this ball to the ground. And the third scenario is when you drop this ball to the ground, the earth, not the ball, moves, goes to the ball. So which one is correct? Okay? Which one is correct? So this is the big problem. Once we don't know, we must decide which the which three scenarios are correct. Which one is correct? So did did Isaac Newton give us correct explanation? Or was Einstein's correct? Or the third scenario was that the earth is going to the ball? Which one? So once again, when you study in school, especially until now, when you're studying about gravity, your teachers will always use Isaac Newton as the source of the topic of gravity. And they will tell you that gravity is when you drop this ball to the ground, there's a gravitational pull, gravitational force of the earth. That is wrong. That is wrong. That is not correct. That is not correct. That is not correct. The reason why that is not correct, because Einstein had discovered it that it is wrong. Okay, so the correct answer, when you drop this ball to the ground, the correct one is that this ball are being pushed by the space, squeezed space, pressurized space. Cause the pressurized space is called gravity, caused by gravity to the ground. It is the space that pushed this to the ground, according to Isaac Newton. Oh, sorry, according to Albert Einstein. Albert Einstein was right when he explained about gravity. And from this, there is no such thing as gravitational force. It is wrong. It is wrong about gravitational force. It is wrong to say that there's a gravitational pull. So the third scenario is that the ball, when you drop the ball and dirt is coming to the ball. No, it is wrong. But possibility, there's possibility, but it's wrong. Now you know that that gravity is just squeeze space pushing this ball to the ground. And this kind of explanation has a very big implication in science, in reality. Especially when you are going to talk about the black holes, the deflection of light, the bending of light, the speed of light, and about the graviton, about space time, cover space, something like that. This explanation we're going to change the way you think about these words, those words that I have said to you. So we are going to finalize our video today. That when you drop this ball to the ground, when you drop this ball to the ground, when you drop this ball to the ground, space is pushing this to the ground. Because according to the general relativity, according to Einstein, this earth, because this earth is inside a space, this earth pressurized space. We are inside the squeeze space. That's why we cannot go up, because we are being squeezed by space. So, which means it predicts that this ball, around this ball, whether it is small or not, whether it's very small, this ball, there is a squeeze space around this ball. There is a squeeze space around this earth. And any object in the universe create a squeezed space or pressurized space. which means all object inside the universe creates gravity. Okay? So, what does it mean? What does it mean? The first implication is that all object, whether the size, whether the shape is round, whether the shape is square, whether the shape is triangular or spherical or rectangular cube. So, assuming that this you put a cube inside a space, then around the cube there is a pressurized, a cubical space around that. We can check that. Somebody must check that. It is predicted that when you put something in the space, it will always create a pressurized and a squeezed space. And I call this gravity, and we call it gravity. And this gravity is I called squeezer, not graviton, not graviton. It is a squeezer. So to those of you who have money or time to buy my science books in Amazon, you can buy my book about the physics of intelligent design, and you can see how I explain that in that book. But this is the first documentary of the topic about gravity. The second video that I'm going to upload to you is that I will explain to you the mechanism of why this ball, how could space push this to the ground. It's very difficult, but once you visualize it, you will understand about bending of lights. You will understand about the curvature of space. You will understand about gravitational waves. You will understand about black holes. There are two kinds of black holes, and you will understand about many things, clocks, time, and many things. But the very most important part is that you will understand what is gravity. That's why whenever you read a science book or see or watch videos wherever, whether YouTube or whatever, wherever, you will always see that their explanation of gravity are wrong. And because they have a wrong explanation of gravity, they have a wrong explanation about black holes, about wormholes, about curvature of space, about space-time, about some people use quantum gravity. What do you mean by that? Or gravitational lensing, or deflection of light, or gravitational wave. You will know that once you understand this explanation. It's very important. It's very important that you understand the topic of gravity in the topic of general relativity. So I'm not saying that, I am not saying that Isaac Newton was stupid. No, no. We can use his formula about gravity when we launch a rocket to the space. It works because his formula is localized. You can just apply in a local area, limited area. The reason why Einstein was correct because Einstein had explained the whole reality, the whole universe, the whole everything that you see, and it works. That's the big difference between the two. So again, gravity is not. There is no such thing as gravitational pull. Forget that. It's wrong. When your teachers or your friend or your relatives or whatever, whoever told you about that, just tell them that's old and they are wrong. Okay? So this will be the first video that I'm going to make to document the topic of gravity and general relativity, because I submitted this this explanation in a science journal, because whenever I read a lot of many side articles in science and they're talking about the gravitational pull of like a gravity, I'm not convinced. They don't understand about reality. That's why thank you for coming here, and I hope that you understand me. If you have a question, please put your question below. So the second video that I'm going to upload is, once again, I'm going to explain to you how it is possible that the space pushes And you will understand that. You will understand what is space, and how it is possible. It's very interesting. This topic is very interesting because once you understand this, I repeat, you will understand about black hole. You will understand many things in science that nobody had taught you correctly. Thank you, and see you again for many videos that I'm going to upload. I was very busy, so I hope that you will forgive my wrong grammar, my wrong English, my wrong diction. And thank you for coming here. And please subscribe and support me. Thank you, and see you again for my other videos. Once again, when I drop this, the space is pushing this to the ground. And that is correct. That is gravity. That is correct. And this gravity I called squeezum, not gravito. Thank you. See you again.